10-3, using chords. These, you have to know the meaning of them, obviously, and understand them. So this is congruent corresponding chords. We know what congruent is. We know that corresponding sides or angles are equal. And then we should know what a chord is. So that kind of gives you the description of what this is. So it says, in the same triangle or incongruent, I'm sorry, not triangle. Oof. In the same circle or incongruent circles, two minor arcs. So I'm going to highlight those little minor arcs, which are right here. Two minor arcs are congruent if and only if their corresponding chords are congruent. So they're showing you the chords right here. Okay, if those chords are congruent, which they're saying they are because they have the congruent marks. If my chords are congruent, then my arcs are also congruent, and vice versa. So if arc AB is congruent to arc CD, they're congruent if and only if your chords are congruent. Please be aware, arc AB is not this way. You're going the shortest distance. So if I'm giving you 2 points and I'm calling that an arc, arc AB is the shortest distance, not the longest. So please be aware of that. Okay, same thing with CD, it's the shortest distance. All right, this one is perpendicular chord bisector. We know what perpendicular is. Okay, lines intersecting at a 90-degree angle. We know what a chord is. And bisector means cut it in half. It bisects it. So this one says, if a diameter of a chord, of a circle, is perpendicular to a chord. So I'm going to highlight, here is my diameter. Okay, so if a diameter of a circle is perpendicular to a chord, here's my chord, then the diameter bisects the chord and its arc. So here's my chord, here's my arc. It's cutting them in half, it's bisecting them, okay, to make them congruent. So if EG is the diameter, which it is, and EG is perpendicular to FD or DF, then HD is congruent to HF, and arc GD is congruent to arc GF. All right, looking at the perpendicular chord converse. Okay, looking at the converse. If one chord is a perpendicular bisector to another, so remember, your diameter could also be a chord. So if one chord is a perpendicular bisector to another chord, there are my 2 chords, it's a perpendicular bisector, then the first chord is a diameter. Then I'm showing you that this right here is my diameter. Okay, so looking at it, if QS is a perpendicular bisector to TR, then QS is the diameter of the circle. Equidistant chords. We should know what equidistant means. It means equal distance, and we're talking about chords. So this one says, in the same circle or incongruent circles, 2 chords are congruent if and only if they are equidistant from the center. So looking at this diagram, here are my 2 chords in blue. So if 2 chords are congruent, they're congruent if and only if they are equidistant, meaning the same distance. So these 2 lines are congruent from the center. Okay, so looking at it, it says segment AB and segment CD. Keep in mind these are not arcs, they're segments because they're giving me my lines, not my curves. So if they're congruent, or they are congruent, if and only if EF is equal to EG, okay? And there's my perpendicular lines, so they're bisecting them, okay? These are also my perpendicular bisectors. So even though it does not go all the way across, technically, yes, it's not my diameter, but if it does intersect it at a 90-degree angle, if it does intersect it perpendicularly, it's bisecting it. Okay, so same thing here. These are also cut in half as well. All right, looking at the examples, let's go ahead and look at A first. So they want us to solve all of these for X and Y, and obviously answer the questions if they do have a question. So with the first one, looking at my first one, I'm solving for X and Y. Let's go ahead and look at it with a couple things that we know. I'm going to draw some arrows because some of this may be a little bit unclear, but let me go ahead. 13 is this line right here. Okay, so this is 13 and this is 5. They want me to solve for X, which is this line, and Y, which is this line. What do I know about that line going straight down the middle? Yes.
The diameter?
That's my diameter. How can I tell that that's my diameter?
Because it's bisecting the...
So yeah, well, yes, I can tell because it's perpendicular. So I have that 90-degree angle right here. So yes, for this one, it's going to be perpendicular chord, bisecting theorem. So I know X and Y are going to be congruent. So you're right. Okay, so looking at this, I'm going to go ahead and solve for X first. So solving for X, what am I going to use to solve for X? Go ahead. Good, I'm going to use my Pythagorean theorem. A squared plus B squared equals C squared. So I'm going to use 5 squared plus X squared equals 13 squared. 5 and 5 is 25 plus X squared equals 169. And subtract 25 from both sides. I'm going to get X squared equals 144 if you subtract it correctly, and then I'm square rooting it to get rid of that squared. So X is going to equal 12. Okay, so if X equals 12, I know that Y also equals 12, and I'm going to write down how we know. This is by the perpendicular chord bisector theorem. And just writing what that is, so we have it. If the diameter of the circle is perpendicular to a chord, okay, perpendicular is key, then the diameter bisects the chord, and we should know the arc. Okay, so that's what we're using for this one. That's how we determined that X and Y are congruent. So again, this is my diameter right here, and because it's perpendicular, both of these segments are congruent, and we should also know that my arc is also congruent. All right, let's go ahead and look at B. I'm still solving for X and Y, and then they're asking me to find the measure of arc AB. So a couple things that we should know looking at this one. This is kind of pointing not to my right angle, but this specific angle right here is going to be 60. So how can I solve for X and Y? What do I know about this? Yeah. Good, I have a special right triangle. I have a 30, 60, 90 triangle. So I'm going to go ahead and draw my triangle and just label what I know. We have 60 right here. We have 30, and I have 90. So they're giving me 6. I'm solving for Y, and I'm solving for X. Labeling what I know. Opposite of 30 is A. Opposite of 60 is a radical 3, and opposite of 90 is 2A. Solving for A, I'm going to go ahead and divide by 2 on both sides. then I'm going to get a equals 3. So y is also going to equal 3. And then if a is 3, plugging it in, x is also going to equal, changing it, 3 radical 3. So I'm just going to write that right here. And then they're asking me for the measure of arc AB. Keep in mind, it's this segment that equals 3 radical 3, and this equals 3. They're asking for the entire arc, A to B. Looking at it, what do I know? What do I know here? What can I find? I know half of it. Good. Who can tell me the measure of half of it? It's not 3 radical 3. So again, this segment is 3 radical 3. I'm looking for the arc. So look at it good. Look at it, examine it. What do I know? I do know half of it. But what is the measure of half of it? Yeah.
I was going to say they're congruent.
They are congruent. Yes, both of these segments right here are congruent. This is congruent to this because I have that bisector right here, so they are congruent. But what's the measure? Yes.
90 degrees.
It's not going to be 90 degrees, so what's 90 degrees is right here. But I think we're kind of getting the idea of we're using some sort of angle. But which angle am I using? Yes. I'm solving for the arc. So I'm not given the arc, but I am given something to tell me what my arc measure is. What am I given? So this goes back to yesterday's lesson with the central angle. Okay, so if I'm looking at this, I have my central angle right here. What is the measure of this central angle? 60. So what should my arc measure be? 60. So if my angle measure right here, we said was 60 degrees, this arc is also going to be 60 degrees. So what should this arc equal? 60 as well. So what do I have to do with them? Add them to get my total, which is going to be 120. Okay, so the measure of arc AB is going to be 120 degrees. Does everybody see that? You have to remember, if they're giving you your central arc, which they are, we said was 60 degrees, it's the same measure as my arc. My central angle is the same measure as my arc, but keep in mind, it has to be your central angle. So yes, even though these are all 90 degrees, that's not my central angle. It has to be from the center of the circle all the way to the end. Do we have questions on that one? Do we all understand that now, how we're using central angle? Okay. Questions on B? All right, let's go ahead and go to C. So looking at C, this one is hopefully fairly easy. Here are my two segments. These are 90 degrees. They're just drawn a little funky. What do I know about these two chords? What do I know about these two chords? Yeah. They're congruent. How do I know that they're congruent? What?
Because the second to the chord is congruent.
Good, because they're equidistant chords. This goes back to equidistant chords theorem. How do I know that they're congruent? Because they're both, the segments are equal distance from the center of my circle, okay? So this one says, two chords are congruent if and only if they are equidistant from the center. And they're giving me those congruency marks. So I do know that this is congruent to this. These two chords are congruent. So what is x? Yeah. X is also going to be 8 because this segment right here is 8 and that's half. So what do I know about y? Y is going to equal 16. That one was pretty easy. All right, questions on A, B, or C so far? All right, looking at example number 2, it says find the measure of arc CD in the diagram. So looking at this, what do I know about this diagram? What do I know about this diagram? Yeah.
That it's the chord is since it's a right angle. Wait, perpendicular chord theorem.
Okay, perpendicular chord bisector theorem. So because I have my diameter and it's perpendicular to a chord, I know that it's bisecting the chord and the arc. So this is congruent to this, and this arc is congruent to this arc, and I'm just going to write it here. This is perpendicular chord bisect theorem. So now that I know that those two are congruent, they want me to solve for CD. So this right here. So now that we know what's congruent, I'm going to set them equal to each other. So I'm going to have 9x equals 80 minus x, and I'm solving for x. So I'm going to add x on both sides of my equal sign. I'm going to get 10x equals 80, and then divide by 10. Am I done? X equals 8. Is that my answer? This is not my answer. I have to do one more step because they're asking for CD. So now I have to plug it in. If arc CD equals 9 times x, I just have to plug it in. 9 times 8, and arc CD is going to equal 72 degrees. Okay, questions on this one? All right, going to the last one. It says in the diagram, circle C, QR is equal to ST, which is 16. Find CU. So what they want us to find is CU, which is right here. And what do I know about this circle? What information do I know is congruent? What do I know here? Yeah. CU and CV are congruent. This is equidistant chords theorem. Okay, and because those two are congruent, I'm going to go ahead and set them equal to each other. So solving for x, I'm going to get 2x equals 5x minus 9. I'm going to subtract 5x from both sides of my equal sign. I'm going to get negative 3x equals negative 9, and then divide by negative 3. Once I divide, I'm going to get x equals a positive 3. Are they asking for x? No, they're asking for CU. So if they're asking for CU, CU equals 2 times x. So segment CU is 2 times 3. And CU equals 6. All right, I'm just going to move this to the side because I'm going to add one more thing on here. So we're solving for CU equals 2x. So I have 2 times 3, and then CU equals 6. Okay, I'm going to add one more thing because you're going to see this in the homework. Okay, so add this on here. We're just going to write, find the radius. Find the radius of circle C. All right, so how am I solving for the radius? Pay attention to how I'm doing this. I'm still looking at my circle. Is there anything drawn on my circle that could give me my radius? Yes or no? Where? How can I find my radius looking at this circle? What am I going to use? Yeah. But are they giving me my diameter?
You can use a perpendicular theorem with the bisector thing, and then just divide the 16 by 2. And then from there, that's just going to be, like, if you divide by 2, that gives you your 8. And from there, you stick up the little stick thing. Because it's already giving you, okay. If you do the line all the way to the end of the circle,
Mm-hmm.
cut it, you said 8 and 8. because it's 16. And then you have your 2x, which you already found is 6. And then using your Pythagorean theorem, you can
Good. Good job. Okay. So what she's saying is, I know it sounds like a lot. If I were to make this a right triangle, okay, if I were to make this a right triangle, I think that's what you're trying to get to, right triangle, right? I can then find my radius. What I just drew is considered my radius. So I do have a right triangle. I solved for CU, and CU we said was 6. And because I know that this is cutting it in half, this segment is going to be what? 8. So now I can solve for a radius. You guys are going to have a question like this, so please pay attention. So solving for my radius, which is right here, I drew that little black line. I just highlighted it in blue. I'm going to go ahead and use my Pythagorean theorem. So I'm just going to kind of redraw that triangle so you could see it. I drew this right here, which is considered my radius. This was 8, this was 6. So I'm solving for my right triangle. So I'm going to use the Pythagorean theorem. I'm going to have 6 squared plus 8 squared equals x squared, which is my hypotenuse, but in this case, it's also my radius. So 6 squared, I'm going to get 36 plus 64 equals x squared. Add these two together, I'm going to get 100 equals x squared, and then square rooting it to get rid of that squared, and x would equal 10. So my radius for this question equals 10. So please make sure you have that written down because you will see a question like that on your homework. And you may see a question like that on your quiz and test. Any questions on that part? All right, good.